Hi students, welcome on this channel. So in today's lecture, our topic is to discuss the moment of inertia of the rigid body with a cavity. As you know that the rotational motion or the rigid body dynamics is very important topic if we look from the perspective of any of the competitive exam, whether it is a JEE Mains or the JEE Advanced, or if you take the NEET exam. So at least like if I take the JEE Mains, so there will be at least two questions from this chapter, and in the advanced sometimes there are 3 questions, 4 questions, and even the 5 questions from this chapter. So this becomes a very important topic. So here in this lecture we are talking about the moment of inertia of a body which has the cavity. We are going to cover the concept of this, and then we are going to solve this question. As you can see on the screen, this is a IIT JEE 2012 problem, so we will solve this question. Okay. Look, it may seem a bit lengthy, these kind of problems which we do for the rotational motion. They may seem you a bit lengthy, but you need to be throughout the lecture, because this is again a very important topic and you might get bored. So in between you can take a pause and you can watch again. You should try the another problems as well, like there has been the questions in the JEE Mains and in previous year JEE Advanced as well, so on the same concept of the cavity, and this similar concept is also there in the center of mass and the gravitation and the electrostatics, where we need to find out, like for example if I talk in the electrostatics, we need to find out the electrical field for a object which has the cavity, and similarly I can also find out the gravitational field because of a rigid body. And the same way, like in the center of mass, if we create a cavity, then the center of mass will shift a bit. Okay, so all these concepts are similar. What we do in these is, first we are going to cover this concept. What if we have a cavity? So like here I have a disk. This is a regular disk. It has the mass m, which is uniformly distributed over the surface. And now they are not saying that what is the mass, whether the initial mass of this disk is m, or after creating the cavity the mass is m, because there can be two kinds of question, especially for the moment of inertia, that initial mass can be m or the final mass after creating the cavity can be m. So if that is the case, then we will have little bit a different approach for both of the cases. Alright, so here that is not given because we need to find out just the ratio. So how do we approach this problem is, like we have this this is our disk, right? If I want to calculate the moment of inertia of this disk with the cavity, okay, this is the disk and I had created a cavity on this right here, and I want to find out at the P point what is the moment of inertia. Okay, now the mass is only remaining in this space. So how do I approach this question is, first I will think that let's find out the moment of inertia of this complete rigid body. So moment of inertia of the complete rigid body, and in that we will subtract the moment of inertia of this body which is removed from that moment of inertia will subtract minus moment of inertia of the object which was at the place of cavity. Let's call it as I cavity itself. Okay, that gives you the total moment of inertia, net moment of inertia at any place, right? Okay, so here we are not going to take this mass negative, we are just doing it like this, that we are taking the complete object, we are finding out the I of this complete object, and then from that we are subtracting the I of the cavity. Now for the I of cavity, generally we will get the dimension, like here I have that the diameter of this cavity is 2r, but we will not have the mass. That mass we need to figure out from the given information. How do we figure out that mass? Is from the mass density, because this object which is removed is also having the same mass density, right? Whatever the mass density is here because I am taking this disk. So for this, whatever the mass density is sigma, the same mass density will be here sigma as well, but the area is different, so that's why mass is going to be different. Okay, so this is the approach. So like for right here, this is our approach for this question or any kind of this question. Okay, now for this question I need to do this 2 times. Why? Because as we read in this question, a lamina is made by removing a small disk of diameter 2r from a bigger disk of uniform mass density and radius 2r in the figure. The moment of inertia of this lamina about the axis passing through the point O and P is IO and IP respectively. Both these axes are perpendicular to the plane of lamina. The ratio IP to IO is nearest integer is, of course, so here we will get some fraction and we need to find out the nearby integer. Look, whenever we read the question, even in the exam, keep in mind that you need to read the question, every information very carefully. In these kind of question, even little statement will make a big sense. Like here they have said that these axes are perpendicular to the plane of lamina. If they say they are in the plane, then it will be something different. The calculation is going to be different, right? Right here they are going to say that you take this point O here and the point P here, and the axis, these passing the axis through these points which are passing are like that. Okay, all right, so let us find out the moment of inertia of this complete lamina from which we have removed the mass, right? First we are finding out the moment of inertia of this complete body. It has, let's suppose, mass m and the radius r. First we are finding out the moment of inertia about the O point of this complete disk. I am calling it as the I1 about the O point. That is going to be, we know that moment of inertia is mr square divided by 2. That is the moment of inertia. Okay, then next is we need to find out the moment of inertia of the part which we have removed about the same point. Okay, so look in this our diagram, this O point is here, right? Let me show you. So here is our O point. So if I take this rigid body separately which I have removed, I need to take this point, and about this I need to find out the moment of inertia of this same rigid body. So first thing is I need to find out whatever the mass is m dash, and the of course the radius is r by 2. Okay, so m dash, what is the m dash? M dash will have the same mass density as of this disk, so sigma multiplied by the surface area A dash. Okay, now sigma, what is the sigma? Sigma is the mass density which we will calculate using this disk. So mass density, as we know here, the mass is distributed on the area. That's why we will use the areal mass density, right? So mass becomes mass divided by area, so that is m divided by radius is r, so that's why area of this disk becomes pi r square. Okay, now let us come to this calculation where we need to find out the mass of this smaller disk. So m dash is sigma A dash, and sigma is m divided by pi r square, and A dash is the area of this smaller disk which is pi, and the radius we know that this is r by 2 whole square. So then it is going to be m by pi r square, and this side we get is pi r square divided by 4. So pi r square is cancelled out, so mass of this disk is going to be m dash, which is m by 4. Alright, so then we can also say what is the moment of inertia about the center of mass. About its center for any disk we know that the I about its center of mass is mr square divided by 2, where m is m dash and r is r by 2 whole square divided by 2. That is going to be m by 4 and r square divided by 4 divided by 2. So this becomes m r square divided by 32. Okay, and then I need to find out about this point O. Okay, so I need to figure out the moment of inertia about the point O. So for that I will apply the parallel axis theorem. So I will say object 2's moment of inertia about the point O is, according to the parallel axis theorem, ICM plus md square. If you don't know what is the parallel axis theorem, I will provide the link in the description. You can watch the video what is the parallel axis theorem and how do we use that parallel axis theorem. There is similar other perpendicular axis theorem, that also I will put in the description and in the comment. Okay, so ICM, the moment of inertia of this disk is mr square divided by 32, and mass of this disk, as we know just now we calculated, it is m by 4, and the distance, perpendicular distance from the center of mass to the O axis is r by 2, so that is r by 2 square. So this from the calculation becomes 3mr square divided by 32. Okay, so now what is the net moment of inertia? So here we are coming to the net moment of inertia of lamina. That is basically I net about the point O is I of the complete body about the point O minus I of the body which we have removed. That is, just now look here, we just calculated this one, which is mr square divided by 2, and in that we need to subtract this 3mr square divided by 32. Okay, so here I net about the point O we are getting is 32, so 16 minus 3 by 32 mr square, so that becomes 13 by 32 mr square. This is the moment of inertia about the point O. Okay, so first solution we have got of this question, this part, what is the moment of inertia about the point O. Alright, now let's go to the second point, P point. So P point is right here, let me highlight, this is the P point. For this P point I need to figure out what is the moment of inertia. The approach would be same. I will calculate the moment of inertia of this complete body. So as we know that the moment of inertia of the complete disk about its center of mass is mr squared divided by 2, and to find out the moment of inertia of the complete body 1 about the point P, I am going to apply the parallel axis theorem, which says ICM plus md square, right? So that becomes mr square divided by 2 plus m, and d becomes r square. I'm getting it as the 3 by 2 mr square, right? And now I need to go to this one, the body which is removed. I know the moment of inertia about this point, just now we calculated about the center of mass, the moment of inertia right here is mr square divided by 32. So I know the moment of inertia about the center of mass. Thus I need to figure out where is the point P, and then I need to find out the perpendicular distance. So look here, I know this moment of inertia of this rigid body about this point, and then I need to figure out about this point. So I need to calculate this perpendicular distance. Okay, so there is this triangle which is formed here, r is r and this is r by 2, and here this is we need to find out d. So d becomes d will be r square plus r square divided by 4 square root, so that becomes 5r square divided by 4 square root. So now if I use the parallel axis theorem, so moment of inertia of the body to about the point P is moment of inertia of the body to about its center of mass plus m dash d square. That becomes mr square divided by 32 plus m is m by 4 and the d square becomes 5r square divided by 4. So this becomes mr square divided by 32 plus mr square divided by 5mr square divided by 16. In total it becomes 11 mr square divided by 32. Okay. Now net moment of inertia of this complete rigid body about the point P is moment of inertia of the body 1 about the point P minus moment of inertia of the body 2 about the point P. That is 3 by 2 mr square minus 11 by 32 mr square. Right? How much is that? That becomes 48 minus 11 divided by 32 mr square, and that becomes 37 divided by 32 mr square. So this is the net moment of inertia of the object to about the point P. Okay, so we have got both of the moment of inertia. Here I have got the moment of inertia of the complete body about the point P, and here I know the moment of inertia about the point O. So ratio of both of them, the moment of inertia of the object about the point P to point O we need to figure out. That is 37 by 32 mr square divided by 13 by 32 mr square. So mr square is gone, 32 is gone, so I am getting this is 32 divided by 13, which is approximately 3. So the ratio of IP to IO is 3. Look here in this question, I have taken this radius, instead of taking it as 2r, I have taken it as r, and then finally because I need to find out just the ratio, so it is not going to affect the total calculation, it will be just 3. Okay, so I hope you must have understood this question, and if you want to look at the more questions of the JEE Advanced, there are the this playlist, you can go through that, and you can also watch other videos of the previous year JEE Advanced questions. And if you like the content, then you can subscribe to my channel. Thank you so much.